Hello, everyone. So today in math, we are going to be talking about subtraction, specifically subtraction word problems. Now, the reason why we're doing this is because last week I noticed that we still are struggling just a little bit with our regrouping when we're subtracting big numbers. But that's okay. We're going to keep practicing. I'm going to show you several different strategies you can use other than just using the standard algorithm or the ones where you just writing it down. I will show you that version too, but we're going to do a couple of different strategies you can use to solve subtraction problems, whether they're just a subtraction problem or they are in a word problem like today. Please watch all of the strategies and then you can try out which ones work best for you. So let's get started. I'm going to be using the same story problem, I should say, for all of the different strategies for subtracting today. So the first thing we need to do, of course, is read the story. I would like you to follow along as I read the story problem. It says, the Midnight Express travels 6,283 miles. When the train reaches Springfield, it has traveled 2,496 miles. How much farther will the Midnight Express travel? So reading this, I now in my head can see that, okay, there is a train called the Midnight Express. So, here we go. It's a train. And the whole distance for this train, the amount that it travels, I know is 6,283 miles. That is a lot of miles, 6,283. And I also know that this train makes a stop in Springfield. And when it makes a stop in Springfield, it has already traveled 2,496 miles. 2,496. Again, that's a lot of miles for one train. Our job is to figure out how much more it needs to travel. So we are going to be using different strategies to solve this problem. One way we can solve this word problem is we can try out the bar model, which is something that we have talked about before. To use a bar model, what you need to do is, of course, draw a bar or a rectangle. I'm running out of room here, but that's okay. So I drew one bar here, and this bar represents the whole length of miles that the Midnight Express train has to travel. And I know that the Midnight Express train needs to travel 6,283 miles. So that is how much this bar represents. You can put it at the end, you could put it at the bottom. It really doesn't matter, whatever makes sense to you. Now, the next thing I need to do is I need to figure out how many miles it has already traveled. Well, I know from the story problem, it tells me right here that it has traveled 2,496. So I'm going to draw a line and I'm going to pretend that this part is how much it has already traveled. Now that I see it in a picture, I now know that there's a big chunk still of time that this train needs to travel. Lots of distance. From here, you can choose a number of different strategies to solve it using numbers. Strategy that you can use to solve this problem is to use an open number line. I already have the number line here set up, and I have the 6,283 written here, which is how many they're going to do in total, how many miles, and I have the 2,496. I wrote them down, up and down, this way just because I don't have a lot of room on this page, but you are more than welcome to write it normally. So to use an open number line, I am starting off with this big number, knowing that I need to subtract down here. I personally think it's a lot easier to make sure that this number turns into an even number, so it ends in zeros. So what I like to do here is I'm going to make a jump in my number line, and I'm actually going to subtract 283 so that my number turns into an even 6,000. That'll make my life a lot easier for getting down to 2,496. So now that I'm at 2,000, or 6,000, excuse me, I want to make some jumps so it's closer to that 2,000 level without going past it. So I'm going to make some 1,000 jumps. So the first jump, I'm going to go back 1,000, which I know is then 5,000 from my 6,000. I'm going to make another 1,000 jump, and I know 5,000 minus 1,000 is 4,000. And then I'm going to make another jump backwards for 1,000. And I know that 4,000 minus 1,000 equals 3,000. Now, it's going to be tempting to just go do another 1,000. But if I do another 1,000, it would actually be past the number that I'm trying to get, which is 2,496. So I can't do that. But a number that's really close to 496 is 500, 2,500. To get to 2,500 from 3,000 is to subtract 500. So 3,000 minus 5,000, I know, is 2,500. And now I'm really, really close to my final number here. If you look, 2,496 and 2,500, they're only 4 away. So really, I only need to subtract 4 to get 2,496, which is the number that I want. Now I'm not done, right? Because now I need to add up, all of these numbers. So how do you do that? Just like I said, you're going to add it up. So it's going to be a little bit of, you know what? Let's do this. Let's go to the next page here. Make it a little easier. So I had 1,000, 1,000 plus 1,000 and 1,000. Because I did 3,000 jumps. 1, 2, 3. So I have those marked down, and I have a 500. So I am going to first do my thousands. I know that 1,000 plus 1,000 plus 1,000 equals 3,000. And now I'm going to add my 500 from this line. Lots of back and forth, sorry about that. 3,000 plus 500 I know equals 3,500. And now I'm going to add my next biggest number, which is 283. So I'm going to add that. I'm running out of room again. 0 plus 3 is 3. 0 plus 8 is 8. 5 plus 2 is 7, and 3 plus nothing is 3. So I'm going to take this number and write it over here. 3,783. And the last one that I did was this minus 4. So I'm going to now add 4 to this problem, which gets me to 3,700, 87. Okay? So my answer is right here, 3,787 miles left to go. Let's try another one. So another way that you can solve this problem is by using this make 10 strategy. This is a way that I often use math to make numbers easier and a little less clunky. So I have written out the problem here already in the way we would normally write it if it was a standard algorithm. right? However, like I said, these numbers are big, they're kind of clunky, and I'm noticing that this bottom number, 2,496, is actually really, really close to 2,500. It's only 4 away. So what I'm going to do is I'm going to take this number and I'm going to add 4 so that it equals 2,500. Again, I want to make these numbers easier. And because this is a subtraction problem, whatever I do the top or bottom, I have to do to the other number. So I can either do that at the end or I can do it right now. I like to do it at the end just because, again, it makes it easier, but it doesn't matter. We'll do it at the beginning for this example. So since I am adding 4 here, I'm also going to add 4 to this number. So 6,283 plus 4, I know, is 6,287. 4 plus 3 equals 7. Now that I have my numbers, I can subtract them. And hopefully if we did this right, it should come out to the same number we got when we subtracted using our other strategies. So let's check. 7 minus 0, I know, is 7. 8 minus 0, I know, is 8. 2 minus 5, I cannot do that. I'm going to have to borrow. So at least I only have to regroup once instead of 3 times in the old way. So here we go. I need to borrow from the 6, so I'm going to turn that into a 5, and that 2 is now going to become a 12. 12 minus 5, that's 7, and then 5 minus 2, I know, is 3. So my answer is 3,787, which happens to be the exact same number we got when we used the open number line. All right, and last but not least, of course, is the standard algorithm. Standard algorithm meaning the traditional way of solving a math problem. So let's go through it. Remember, as always, when we are subtracting, we need to make sure that we are starting with the ones place. And you're going to look at the top number and you're going to look and you're going to see, is this number bigger or smaller? I notice that 3 is smaller than 6, which means I'm going to have to borrow or regroup. Who am I going to borrow from? To the neighbor on the left. So in this case, the 8, which is in the tens place value. So I'm going to need to borrow a 10 from this 8. What that means is I'm going to have, instead of 8 tens, I am now going to go down to 7 tens. Now, instead of having 3 ones, I'm going to have 13 ones. And now I can subtract. 13 minus 6, I know, is 7. So I'm going to write that down. Now I get to move on to the next place value, which is our our tens. We have 7 tens in the top number, and we have 9 tens in the bottom number. That doesn't work again because 7 is too small. You cannot take 9 things away if you only have 7 of them, right? So now we need to borrow or regroup again from our neighbor to the left, which is our 2. So we're going to take away our 2 and we're going to turn it to a 1, and our 7 is now going to become a 17. 17 minus 18, I know, equals 8, so I'm going to add an 8 there. Now we get to go further left in our problem, and I'm going to do 1 minus 4, but I can't, because if I have one thing, I can't take away 4 of them, right? I'd be in debt. I don't want to be in debt, so I'm going to have to borrow from the neighbor. So the 6 is then going to be turned to a 5, and that 1 is going to be turned into an 11. 11 minus 4, I know, is 7. And now the last place value I need to subtract is the thousands place value, 5 minus 2. I think that's the easiest one because you don't have to regroup. 5 minus 2, I know, is 3. And so my answer is, once again, 3,708. Oh, sorry, let me say that again. 3,787. There we go. I can talk, you guys. So, anyway, there are many, many different ways you can solve this problem. None are wrong, none are better than the other. You need to pick which works best for you. Don't pick the one that, oh, this is what everybody else does, because numbers work in mysterious ways and they are amazing, and there are many ways to solve one problem. You might think that the person sitting next to you is solving the problem the same way, but more than likely they're not. So it's really, really important for you to pick which way works best for you.